Good evening, engineers. Today I have the topic for you which I want to discuss here, that is grade of concrete. How many types of grade of concrete we have and where we use them and how we shift from nominal mix to design mix. So let us discuss here grade of concrete. Grades of concrete. There are various types of grades of concrete. In PCC, we use M5, M7.5, M10, M15, and above M15 for the RCC structures with M20, M25, M30, M35, M45, and so on, depends upon the conditions, site situation, type of structures, environmental conditions. So let's discuss about, we have PCC and we have RCC, plain cement concrete and reinforced concrete. In PCC we mainly use M5, M7.5, M10, M15, and in RCC above M15 we use M20, we use M25, we use M30, we use M35, we use M45, and so on. Now, what is the ratio of M5? What is the ratio of 7.5? And so on. What are the ratio? So, M5 we have 1:1, 1:5:10. M7.5 1:4:8. M10 1:3:6. M15 1:2:4. M20 it's 1:1.5:3. M25 1:1:2, and these M30, M35, and so on, they come under design mix. We design them, and after designing and after having various tests, we calculate the ratio proportion. So here I just want to say you one thing. For example, we have M15. What is M and what is 15? Here M denotes the mix and 15 denotes the characteristic compressive strength of the concrete. For example, for M15 we have 15 Newton per mm square, its characteristic compressive strength. So, how do we know that M15 has 1:2:4 ratio and M20 has 1:1.5:3 ratio? So, I just want to say you that IS 456 2000, it gives us some details in table 9 under the heading of proportion for nominal mix concrete. So I just want to share a screenshot with you where you are seeing that we have grade of concrete in the first column. We have total quantity of dry aggregate by mass per 50 kg. We have proportion of fine aggregate, coarse aggregate, and we have in the fourth column quantity of water per 50 kg of cement. So for making the things clear and obvious, I just have written, just copy paste the table 9 of IS 456 here, and I will show you that in table 9 it says proportion for nominal mixed concrete. If we have M5, 7.5, 10, 15, 20, what will be the proportion of the concrete? How will we evaluate these things? So for example, let's take grade of concrete M20, and in the second column it is saying total quantity of dry aggregate by mass per 50 kg of cement, both fine plus coarse aggregate in kgs. And in the third column it is saying proportion of fine aggregate to coarse aggregate by mass. For example, and for water we have per 50 kg of cement, how much water we need, maximum water, how much maximum water we need. So let's take the example of M20, and here fine aggregate plus coarse aggregate have been given as 250 kg. Okay, and the ratio of fine aggregate to coarse aggregate, we usually, I say generally 1:2, we take generally 1:2. So let us utilize M20, let's use this M20 and get the calculation of proportion of M20 by using these details. So for example, we have M20, or we can use M10 also. M20, or we can use M20. What does the IS 456 under table 9 say? If we have M10, for M10 we have 480 kgs of fine aggregate plus coarse aggregate. So let us take, what is the ratio of so let's take X is equal to fine aggregate Y is equal to coarse aggregate. So I says quantity of dry aggregate by mass per 50 kg of cement, fine plus coarse, is equal to, in case of M10 it is 480. So let's take X plus Y is equal to 480 kg. Also in column third it says proportion of fine aggregate to coarse aggregate, that means its ratio, that means Y is to X is equal to 2. Their ratio, proportion of fine aggregate to coarse aggregate, 1:2 says. That means aggregate is Y is 2 times X. Let's put this Y is equal to 2X in this equation. So X plus, we have Y is equal to 2X, so we will write it 2X is equal to 480 kg. So 2X plus X is equal to 3X is equal to 480 kg. So X will come out to 480 divided by 3 kg. So X will come out to be 3 ones are 3, 3 6 are 18, and 6 are 18, 3 is 163 point. Let's calculate it. 480 divided by 3, 160. kg. Okay, So let's put this x in this equation to get the value of y. So x plus y is equal to 480, and here we have x is equal to 160 is plus y is equal to 480 kg. Y is equal to 480 minus 160, which will come out to be 0 8632 413 320 kg. That means now we have cement. As we can see, it says per 50 kg, and here too it says per 50 kg of cement. That means for 50 kg of cement, then 50 kg of cement we have x fine aggregate, 160 kg of sand is to, and 320 kg of aggregate. This is the ratio we get. So if we divide the whole things by 50 to get the exact ratio 50 kg, so 50 kg divided by 50, 160 kg divided by 50, and 320 kg divided by 50. So here we will get 1 is to 5 3s are 15, 5 2s are 10 is to 5 6s are 30, 5 4s are 20. So we get the ratio of M10 as per the IS 1 is to 3.2 is to 6.4. What is the actual ratio? What is the ratio we usually use? The ratio is M10 is 1 is 3 is to 6. So here these decimals we don't use them, and we just say let it be 1 is to 3 is to 6. That means 0.2 and 0.4 we don't take these, and we say that M10 is 1 is to 3 is to 6. So this is how we get the ratio. So grades of concrete M5, M7.5, M10, M15, these are the grades of concrete, and up to M20 or 25 without any hindrance we can just use these ratios at the site and execute our work. But for M30, M35, M45 we have to first get the design mix, and then afterwards we can execute the concreting and various other things at the site. So if a person want to calculate the cement sand quantity or aggregate quantity per cubic meter for any of these ratio up to M25, let's suppose it is M25, we here take nominal mix. So why I just want to see you that M15, for M15 we can calculate the quantity of cement, sand and aggregate. But I am taking here M25. I just want to say you that for M25 we will get the quantity of cement, we will get the quantity of aggregate, we will get the quantity of sand, but the quantity of cement will be very high as compared to the design mix M30. Let us see, let's calculate the quantities that will be calculated from the proportion of grade of cement M25. Calculation of cement, sand and aggregate of M25. Let us calculate. Consider 1 cubic meter of volume. Let's say were calculating the quantity of cement, sand and aggregate for 1 cubic meter of concrete. So consider volume of concrete is equal to 1 cubic meter, but it is a wet volume. That means, for example, let's take a structure, say column. The concrete which we put in a column, which is used in a column structure, that is a wet volume. We just mix the dry volumes, sand, cement and aggregates to get the wet volume, but the volume of dry condition will be more. So dry volume is equal to wet volume plus 54% of wet volume. That means we say that if we have 1 cubic meter of wet volume, so dry volume will be equal to 1 plus 54% of wet volume, that is 1, which is equal to 1.54 cum. That means dry volume is always greater than wet volume by 54%. So here we have calculated the dry volume as 1.54 cubic meter for wet volume of 1 cubic meter. Okay. So now we have to calculate the quantities of M-25. We know that M-25 we have ratio is equal to 1:1:2, where this 1 indicates cement, this 1 indicates sand, and this 2 represents aggregate. So in M-25 or in any concrete grade where the ratio is 1:1:2 or 1:2:4, whatever, the first ratio represents the cement, second one represents the sand, and the third one represents the aggregate. We always calculate quantity of cement, sand and quantity of aggregates by taking dry condition. We never take wet condition, as we have to calculate the quantity of cement, sand and aggregate. For that we always take dry condition. We always take dry condition. Whenever we cast anything, for example, we cast beam, or we cast column, or we cast any slab, that casting represents the wet volume. So to get the dry volume of that wet volume, we always increase the wet volume by 54%, as I have done it here. Wet volume will be always greater than dry volume will be always greater than wet volume. So for to calculate the cement, sand, aggregate, we consider dry condition, where it is 1.54 cum for 1 cum of wet volume. Okay. In order to calculate the quantities, let's take the ratio of M-25, which is equal to 1:1:2. So as this is cement, represents Sand, it represents aggregate. Let's take the sum of the ratios. Sum of ratios, which will come out to be 1 plus 1 plus 2, which is equal to 4. So let's calculate this quantity of cement for 1 cubic meter of concrete cement. So we have one is cement divided by sum of ratios 4 into 1.54 volume in dry condition, volume of concrete in dry condition. That's why I told you that to calculate the cement sand aggregate, we always take dry condition. So I took the dry condition here, which will come out to be 1.54 divided by 4, 0.385 cubic meter. If this is in cubic meter, if you want to get the kg in kgs, then just multiply the cum with density of the cement, which is 1440. It will come out to be the kg into 1440. It will come out to be 554.4 kgs. If you want to get the cement quantity in the CFT, cubic feet, we know that one bag of cement has volume of one bag in CFT is equal to 1.226. So we just have to multiply the number of bags with this number. We will get this quantity in the CFT. So number of bags will be, we have 554.4, just divided by 50, we will get 11 approximately. 11 bags. So CFT will be equal to 11 bags into volume of one bag in CFT 1.226. It will come out to be 11 into 1.226, 13.486 CFT. This is the quantity of cement how we get. Next we have sand. We have M-25 1:22. So here we do the calculation of the quantity of the sand in cubic meter. We just use a ratio of sand divided by sum of ratios is equal to 4. Into volume in dry condition. It will come out to be as same as cement, 0.385 Q. If we had to calculate the sand in kgs, we just have to 0.385 into density of sand. And density varies. That's why I am not calculating the exact value here. Density values from 1450 to 1500 kg per meter cube. So depending upon density, we can get the sand quantity in kgs. If you want to get the sand in CFT, square cubic foot, so just 0.385 we have already got it cum into 1 cubic meter is equal to 35.3147 CFT. So this multiplied by 35.3147 will give us the sand quantity in the CFT, which is equal to 0.385 multiplied by 35.3147, 13.59 CFT. Let us check. 35.31. Sorry. So we get the in CFT and in cubic meter. For calculation of the aggregate, in cubic meter, the ratio of the aggregate is 2 divided by the sum of the ratio of the proportions divided by 4 into volume in dry condition is equal to 1.54 multiplied by 2 divided by 4, 0.77 cubic meter. If you want to get the quantity of the aggregates in kgs, just same thing, 0.77 cubic meter into density. Its density varies from 1450 to 1600 kg per cubic meter. Get the density of the aggregate, multiply with the cubic meter, so you will get the aggregates in kgs. If you want to get the aggregates in CFT, then what you have to do, just the quantity in cubic meter multiply by the same 35.3147, you will get in cubic foot 0.77 multiply by 35.3147, 27.19 CFT. Let us check. 0.77 multiplied by 35.3147, 27.19 CFT. So these are the values. This is the calculation of the sand, cement, aggregate in M-20 grade of concrete. So if just you want to calculate the water quantity, how much water is required in 1 cubic meter of the concrete. If you want to get 1 cubic meter of concrete, how much water you should use? So if you want to get the water quantity, let's suppose our water cement ratio is 0.45. If our water cement ratio is 0.45, so water is equal to 0.45 into cement kgs. So water is equal to 0.45 into how much cement we have utilized for 1 cubic meter. We have already calculated that we have 554.4 kg. 554.4 kgs. So let's calculate this. 0.45 multiplied by 554.4, it will come out to be 249.48 kgs. As the density of the water is 1, approximately 1, so we can say which is equal to 249.48 liters. This is the quantity of the water which will be used for the formation of 1 cubic meter of wet volume of concrete. In simple words, I want to say you what is this 1.54 that we use. If you want to get 1 cubic meter of wet volume, we have to use 1.54 cubic meter dry volume. This is the actual thing. If you want to get 1 cubic meter of wet volume of concrete, we have to utilize 1.54 cubic meter of dry volume. If we will use 1.54 cubic meter of dry volume, after mixing it, the volume will decrease and we will get 1 cubic meter of wet volume. Hope you enjoyed this topic, and in the next lecture I will have another topic for you. So till then, goodbye, Allah Hafiz.